Hello everyone. In this small bit, we are going to study the forces acting on the spur gear. Actually, in case of gears, there are three types of forces are acting. One is the radial force, one is the tangential force, and one is the axial force, which is also called as the thrust. But in case of spur gear, that thrust force, which is zero, because that teeth are parallel to the axis of rotation. That's why that axial thrust acting on the spur gear is zero. That's why here we have to consider only two types of gears. One is the radial force and one is the tangential force. One important thing that you should know or you should remember while studying any type of gear. In all the type of gears, only tangential force which is required to transmit the power. Radial force which tries to separate two gears radially and axial force which tries to separate two gears axially. Only important force which is the tangential force which transmits the power or the motion or is responsible to transmit the motion. Okay, now just consider this geometry. In this geometry, as we know that point of contact which always moves along this common normal, that common normal is the mn, and that common normal must pass through the pitch point as per the law of gearing. Only after that we say that this gear which satisfies or this gear base satisfies the law of gearing. Okay, now this point of contact which transmit one force which is the resultant force which is the F, and that if we which separate again this phi is the pressure angle. Now if you draw one right angle triangle, that force which is parallel to the line joining two centers which is called as the radial force, and one force which is tangent to the pitch circle which is the tangential force. That tangential force which is always tangential to the pitch circle only, not the base circle which is tangential to the pitch circle. Okay, there are two components. One here we have to consider two components. One is the tangential component which when multiplied by the pitch line velocity will find out the output power, and second one is the radial component. Okay, now we'll find the relationship between Fr and the Ft. Here we find out Fr. If we consider this right angle triangle, Fr is equal to Ft tan phi, where phi is the pressure angle. Again, I want to find out the total power transmitting power. That power transmitted is equal to Ft into V, where V is the pitch line velocity. That means the velocity of this gear. V is equal to R into omega, where R is the pitch circle radius of this gear O1P into its angular velocity. Otherwise, you can also write it like this, capital R into omega 2. But this is the omega 1 or R into omega 2. In this way also, we will find out the total power. Now, when two gears are in mesh, this is one tangential force. This gear which rotates in the clockwise direction, that tangential force which is moving towards right hand side, this is the pitch point, and that radial force which is in the upward direction. Again, here you will find that radial force which is in the downward direction. That means these two forces are trying. That means this is the same forces, Fr, Ft, Ft. This force which is towards the left hand side, this is the right hand side, this is towards the left hand side. This radial force which is in the downward direction, this radial force which is in the upward direction at the point of contact or at the pitch point. This Fr tries to separate these two gears along the radial direction, and tangential force which is transmit the power. Okay, that phi is the pressure angle. In this way, we have to study the law of gearing. While solving the numericals, that power will be given to you. P is equal to T into omega. Power is equal to T into omega. T is equal to Ft into R. P is equal to T into omega. T is equal to torque is equal to Ft into R. That Ft, which is the tangential force, that R will be given to you, that omega will be given to you, that power will be given to you. You can find out the Ft, tangential force, and from this tangential force you can find out the radial force. In this way we have to solve the numericals based on this force analysis. With this we are going to finish our unit number 1. Thank you for your patience listening. Thank you.